Hello and welcome to this Swift programming video. My name is David Thorne, and in this video we're going to be talking all about bitwise AND operators. Now you may have seen already the logical AND operator. Now they're not necessarily the same thing because the logical AND operator is just working with Boolean values and then just flicking it over to false or false to true, like toggling it backwards and forwards. All right, and checking to see whether something is true or checking to see if something is false. And the bitwise AND operator is not doing that. All right, it's working at a bit level. And so for that said, let's just give a quick example, and then I'll go into depth about all of the different things. So here we have then two 8-bit unsigned integers, okay, and one is then using the binary format is then 1 0 1. Obviously that's being 1. And then 4 is activated. This is then going to be 5. And here we can see 2 is activated and 8 is activated. This is then going to be 10. All right, so this is 1 is not activated, 2 is activated, 4 is not activated, 8 is activated. All right. So what we want to do is use a mask. And in this mask, we are then just going to say print here. And in the previous video, we created this binary string extension just to help us to visually display this. All right. So if we just say number and then say and, this is the AND operator here now, not the double AND. That's the logical AND operator. This is then just the bitwise AND operator here. And what we're going to do, which I'm going to explain in a second, we're going to take this and we're going to say here binary string, and we're going to run it, and we now show you that it's then all zeros. Okay. Now, why is this all zeros? Well, we can see that all of these zeros and ones are all matching up with one another. And when we say in binary 1 plus 0, right, we are equaling 1. Okay, and when we're saying 0 plus 1, we're saying 1. And when we say 1 plus 1, we equal 1 and then carry the 1. All right, well, that's all well and good. But with an AND operation, we are saying that the first bit has to be 1 and the second bit has to be 1 for it to equal 1. Now, if the first bit is 0 and the second bit is 1, that equals 0. And if then the first bit is 1 and the second bit is 0, that equals 0. And then if the first bit is 0 and then the second bit is 0, that's going to equal 0 too. So this is a list of all of the different options that are available. So you are only ever going to get 1 when both bits are activated. They have high voltage or whatever you want to call it. They're all 1. So here you can see that the least significant bit is 0 on the mask. And then we are saying that we don't care about this bit. So at no point, it doesn't matter whether the least significant bit on the number is 1, because it's just going to ignore it anyway. It gets to the second and then it ignores that. And they're going to ignore all of them. So, however, if we just pop a 0 on the end, and we now move this down, you can see now we are getting 5 and 5, right? So 1 and 1 is going to equal 1. 0 and 0 is going to equal 0. 1 and 1 is going to equal 1 once again. So when we run this again, you can see that we are getting 1 0 0 1. Now, why would you want to do this? Well, if all of these bits were on an electronics board and they relative to a sensor or something like that, there could be that we've got 2, 3, 4, 5, 6, 7, 8 sensors, and we want to know, is this sensor active and is this sensor active? Here we don't really care about the binary value of it, right? Because these are all just connected to a wire, and we want to know, hey, is this sensor and this sensor activated? All right. And so when we run this, we can now see we get 0 0 0 0 0 and then 1 0 1. So we know that this is non-zero. Well, if both of these sensors weren't activated, you can see that we get 0. So here we can use the bitwise AND operator in the likes of electronics. And let's just say like test subject here, and we're going to say then number and then mask and then here, and here we can then turn around and say if test subject is equal to 0, right, and say then sensors not active. Else you can say, you can do the work here, sensors are active, right? And when we run this, we can see sensors not active. But if we now requiring these two bits to be active, and let's make this bit not active and this bit not active and this bit not active, and we run this again, you can see sensors are now active. So this is a reason why you would want to use the bitwise AND operator to check to see whether specific bits within inside of the other bit are active. Now, in the previous example we showed you, or in this example, we're looking here to convert the unsigned integer with 8 bits. We can see here that we are using the AND operator here, and this is nothing more than saying 2, 3, 4, 5, 6, 7. Nothing more than saying this to show you exactly the same thing, but we don't need to write all of the zeros here because we can just say in base 10, 1, right? So this is exactly the same thing as writing that because we're just leaving off all of the zeros here. So when we're saying AND operator, what we're doing here is we're saying, hey, we want all of these bits here to be checked off with each other, whether or not they're both 1 and 1. And if they're not, then they're just going to be 0, as we just discussed here. So this is the bitwise AND operator. You might think that you don't need it, but if you're going to start moving towards the likes of electronics or sensors or even communicating through binary, and you want to be able to check in the fastest way whether that answer contains the information that you want, or the bits inside of it are activated. Because if you don't care about, say, 25 of the bits, but you only care about, say, like 8 of them, then this is the way you can use the mask for it. And you might think, well, this is not very common, but when you look at your network mask on your router, you've got like 192, 168, 178, 1, and so on. So this is doing exactly the same thing. This is looking at a packet that's coming over your network, and it could say, hey, or on the router, and it could say, okay, which network is this one packet available? And it can check to see against the network mask. And then if all of these bits are activated, then it knows it's going to this one network, because this is the host section where the 0 is, and this is then the network section. So you already seen this all the time through the likes of IP addresses using the bitwise AND operator the whole time. With that said, I hope that you've got something out of this one video. For the normal Swift UI parts of it, you don't really have to care about bitwise AND operation. But when you start looking at doing using lots and lots of data and so on, going down to the lowest level at the memory level starts to provide you with lots of efficiency. That's why it's worthwhile understanding how to do bitwise operations to shift bits backwards and forwards. Okay, with that said, thank you very much for watching. Don't forget to like, subscribe, share, and do all of the other social media things that you can do to this one video. If you've got any questions, comments, or concerns, as always, let's start a conversation in the comment section down below. My name's David Thorne. Thank you very much for watching. See you in the next video. Ciao, ciao, and goodbye.